Let's continue our discussion about L'Hopital's rule. Now, in an earlier video, we saw that there were two cases where we want to use L'Hopital's rule. It was 0 over 0 or infinity over infinity. It doesn't matter what the sign was. So in those two cases, we can use L'Hopital's rule. Okay, so what we want to talk about in today's video is something we call an indeterminate form we call indeterminate products. So what's an indeterminate product? Well, just like 0 over 0 doesn't really make sense, and infinity over infinity doesn't really make sense, an indeterminate product has the form 0 times infinity. And this product also doesn't really make sense. You know, which goes faster? Does the first part go to 0 faster, or does the second part go to infinity faster? It's sort of like a race to see, how do those speeds relate to each other. So the key idea for us is we are going to manipulate the expression f times g. These are the two functions that are being multiplied to each other, and try to manipulate it so that we express this product in the basic indeterminate form. And by that, I mean either 0 over 0 or infinity over infinity, so that we could use L'Hopital's rule. So what is that going to look like, really? Well, if you started off with your f times g, and one of them is 0 and one of them goes to infinity, well, we could really rewrite that as either g divided by 1 over f, or we could write that as f divided by 1 over g. And when we rewrite things in this way, then if g is going to infinity, then this first part here would be infinity over 1 over 0. 1 over 0 goes to infinity, so this one becomes infinity over infinity. If I rewrite it the other way, in other words, if I leave the f on top and I rewrite multiplying by g as dividing by 1 over g, then the f is going to be a 0 here, and the 1 over g, 1 over infinity, is going to be 0 as well. So this first one gives you infinity over infinity. The second one gives you 0 over 0. Okay. Let's take a look at an example and try to use this example to help us understand the indeterminate products. So we're going to take the limit as x approaches 0 from the positive side, and we're going to have x times natural log of x. So this is the classic 0 times infinity situation. So what we're going to do is we're going to rewrite this as the limit as x goes to 0 from the positive side. Why don't we leave the natural log of x in the numerator, and we'll rewrite multiplying by x as dividing by 1 over x. So we know that dividing by a fraction is the same thing as multiplying by the reciprocal. So when we do that, really we could take this, we could rewrite it as the limit as x goes to 0 from the positive side. Think of this as natural log of x divided by x to the negative 1. Writing it in exponential form makes it easier for us to take our derivative. So at this point, we can see that as x approaches 0 from the positive side, we're going to get an infinity over infinity, which means we could use L'Hopital's rule. So we put an equal sign, we put the little LH there, and then we're going to take the derivative of the numerator and divide by what we get when we take the derivative of the denominator. So the derivative of natural log of x is just 1 over x, and the derivative of x to the negative 1 is negative x to the negative 2. Okay. When we can simplify this fraction, when we simplify this fraction using algebra, what are we going to get? We're going to get the limit as x goes to 0 for the positive side. This becomes negative x to the negative 1. And remember, when you're dividing two things with the same base, you're going to subtract the exponents. So this will be minus negative 2 like that. So my limit becomes the limit as x goes to 0 from the positive side. And that part simplifies to negative x to the first power, because negative 1 plus 2 is equal to 1. All right. At this point, I could just plug in a 0 in for x, and I'm going to get 0. So that's going to be my answer for example 2. Let's take a look at example 3. When I look at example 3, I can see I want to calculate the limit as x approaches negative infinity. We're going to have x times e to the x. So plugging in a negative infinity is going to give me negative infinity for x. And then we know that e to the negative infinity, that's going to be 0. So this is negative infinity times 0. Again, this is the classic indeterminate product. So we are going to change the way this looks. We're going to manipulate this expression. So let's do that. So this becomes the limit as x approaches negative infinity. And what I'm going to do is I'm going to leave the x up top there. And I'm going to, multiplying by a number is the same thing as dividing by its reciprocal. So I'm going to rewrite this as 1 over e to the x. So these two expressions are now the same. Okay. I could change that denominator and rewrite it in exponential form. So this becomes x goes to negative infinity, x divided by e to the negative x. And what happens when I plug in a negative infinity now? Well, the numerator goes to negative infinity. The denominator is going to be e to the negative x. That's e to the infinity. E to the infinity is infinity, so we get infinity over infinity. This means I can use L'Hopital's rule. So I put an equal sign with a little LH there, and then now I calculate my limit. I take the derivative of the numerator. The derivative of x is just 1. I take the derivative of the denominator. When you take the derivative of the denominator, don't forget that we want to use the chain rule. The inside function is negative x. So the derivative of this outside function is e to the something. You keep the inside, which is negative x. Going to multiply by the derivative of the inside. The derivative of negative x is negative 1. Okay. So finally, we could, plug in our x now. The numerator is 1. The denominator, we're going to have e to the negative infinity, so e to the infinity. That's going to give you a positive infinity. And then when we multiply by negative 1, that's going to give you a negative infinity. So the numerator is a constant. The denominator here blows up. So anytime you have a constant over some sort of infinity, that whole thing is going to go to 0. So this limit is equal to 0. All right. And we're going to highlight that because that's our answer. All right, everybody. I hope you enjoyed this video on indeterminate products. Take care.